Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of constant acceleration. Whenever you have constant acceleration, there are groups of equations that arise that allow us to calculate velocity, time, distance, or acceleration, depending on what you're given. I don't recommend memorizing the equations. I do recommend doing a bunch of problems and the equations will become second nature. So when dealing with these equations, you're going to come across some terms. So the first term is initial velocity. V naught x is the way that's pronounced, or V naught y is the initial velocity in the x direction and the initial velocity in the y direction, respectively. Velocity at time t will be indicated by a subscript of x or y. The distance at time t will be equal to x sub m if we're in the x direction, or y sub m if we are moving in the y direction. Initial distance, again, subscript 0 or O means not and signifies the initial. Whatever the big one is, if there's an O attached to it, it's the initial of that thing. Time, pretty straightforward. Acceleration in the x or the y. Alright, so first group of equations is going to be whenever you have distance equal to the initial velocity times time plus 1/2 acceleration times time squared. If the motion is in the x direction, you're going to have x sub m minus x naught, otherwise known as delta x, equals V naught x, the initial velocity in the x, times time plus 1/2 axt squared. And if the motion is in the y direction, the only thing that's going to change is the x's now become y's. Okay? Acceleration in the y direction is going to be negative 9.8 meters per second squared, or negative 32.2 feet per second squared, depending if we're on metric or standard system. So the next equation we're going to look at is velocity squared equals initial velocity squared plus twice acceleration times change in distance. Again, the only thing that will differ is that x and y if you're traveling in the x direction versus the motion in the y direction. Alright? So again, try to do as many problems as you can with these. Don't memorize them. Go ahead and write them down now as you're watching the video, because you will need them during your problems, or if your teacher or tutor was nice enough to give you a formula sheet, then lucky you. Alright? But don't doubt your mind. Your mind can absorb this and much, much more if you only have faith in it. This equation here has to do with the change in distance related to the velocities. Alright, so if you're traveling in the x direction, it's going to be x sub m minus x naught, average of the velocities times time, so initial plus actual velocity at time t. Same thing for the y's. And the final equation has to do with, again, the calculating the velocity at time t. But note, these are equations. You could be given multiple variables and be asked to calculate the initial velocity or the acceleration. Okay? Any equation you can have any of these be an unknown given the other quantities. So these are the basic equations that you're going to have to deal with when solving the constant acceleration problems. If acceleration is not constant, then integrals come into play and a little calculus, and we'll deal with that on a different video. Alright? So I hope I've clarified things for you, enough for you to practice and start these problems with these equations. You should be able to do pretty much any constant acceleration problem. The main thing I've seen people have issues with is knowing which equation to use when. And the best way to alleviate that issue is to practice as many problems as you can. Alright? So, as always, practice, practice, practice. Thank you and have a nice day.